Okay, so I want to take special angles, multiples of 30, 45, and 60 degrees, label each angle using degree and radian measures, and use a positive rotation. Okay, so positive rotation here means we're going to go in the clockwise direction. I'm sorry, counterclockwise direction. Okay, so we're going to start here on the what would be our x-axis, right? And so that will be 0 degrees. So when we come up, not really sure what that is. That's just a line for right now. So I know this is 90 because we've talked about that before. Over here is 180 degrees. Okay, and then down at the bottom is going to be our 270 degrees. Okay, so I'm looking, and this appears to be halfway between the two. So half of 90 is 45 degrees. So I think each one of these being about the same size is a movement of 45 degrees. So I'm going to add 45 degrees here, and that's going to be 135 degrees. Another 45 degrees from 180 would be 225 degrees. And then from 270, another 45 degrees would be 315 degrees. Okay. Now, for the radians, a little bit, we still are at 0 degrees, or 0 radians. Okay. We've talked about before, 90 is the same thing as pi over 2. Okay. 180 is pi. And 270 was 3 pi over 2. So now what do we do about 45 degrees? Well, if we count here, we have 1, 2, 3, 4 sections. So we've divided this 180 degrees, or pi, into 4 parts. So that means this is 1/4 of pi, right? Or simply pi over 4. Okay. So over here, this is 1, 2, 3/4 of pi, okay, which would be 3 pi over 4. Okay. So if we continue on around, 5, 6, 7, 8, this 225 degrees would be 5 pi over 4, and 315 degrees would be 7 pi over 4. Okay. So that's how we deal with radians and degrees when we divide the circle into 8 even parts, which is 45 degrees. Okay. Let's see. Oops. Let's get rid of some of those extra lines. Actually, let's move over here. Okay, so this second section here, this is our, I'm not sure how many parts are there, so let's go ahead and count that up. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, okay, 12 parts. All right, so looking at 12 parts, okay, since my whole circle is 360 degrees, I could say 360 divided by 12, which is 30. So I know each section is 30 degrees apart. So I go 30, then this would be 60, 90, 120, 150, 180. Then continuing on, 210, 240, 270, 300, 330. Okay. All right, and then we come on around, and this would be 360 degrees. All right, so what about with the radians? We know that this is still 0 radians. Over here we have pi radians. Okay. 90 is still pi over 2. Right. 270 is still 3 pi over 2. Now how do I get the others? Okay, well I divided this top section into 6 parts. So that means this is 1 pi, or pi, over 6. Okay, so this 60 is 2 pi over 6, but 2 pi over 6 reduces down, so that's actually going to be pi over 3. Okay? Right? Coming on around, right? We now have 4 pi over 6, and so 4 pi over 6 right here is actually going to be the same thing as 2 pi over 3. Okay. Coming one more, that's 5 pi over 6, which doesn't reduce. Okay. Now we have 7, so 7 pi over 6. 8 pi over 6, which would reduce down to 4 pi over 3. Here at 300 degrees, we're at 10 pi over 6, which would be the same thing as 5 pi over 3. And then 330 is our 11 pi over 6. Okay. Now I do want to point something out here. This is, we have 30 and 60 degrees. 30 and 60 were both special angles from when we studied right triangles. So I want to point out that all of our multiples of 60, 60, 120, and then over here 240 and 300. If you look really closely, you'll be able to see that that would be if we divided our circle, or at least dividing pi into 3 parts. So 60 degrees, right, is the same thing as 1/3 of pi. So we have it here and here, and you'll notice that all of those radians have a 3 denominator, whereas our 30 degrees have a 6 denominator. Okay? All right. Thanks very much for paying attention.